Everybody, let's do some examples of some dynamics problems. So let's continue with the Atwood's machine theme. So that's the one with the pulley and then the two blocks. But let's modify it. Let's say there's like a surface and then the pulley's here. I put a block over here connected by a string that goes to a block over here. Okay, and let's say this surface is smooth. Smooth means, right, normally there's like this block, there's a contact force, right? Which contact force decomposes into normal force and friction. If this friction component is negligible, we say the surface is smooth. So let's neglect friction this week. We'll talk about it next week. Okay, so this is smooth. And then let's say the pulley is massless. This will come into play later as well. Because if the pulley is massless, the tension here is the same as the tension here. That will change later as well. Okay, so let's say you let these go from rest, right? So this block's going to go that way. This block's going to go that way. Let's draw the free body diagrams, right? So let's do the steps, right? Steps. Draw the free body diagram. Pick coordinates. Then we'll write Newton's second law. And then we'll solve the math. So step 1, free body diagram. So free body diagram of block 1. Free body diagram of block 2. So here's block 1, free of its surroundings. You draw all the forces acting on the block. Okay, so there's that rope with tension. I'll write T for tension. The block itself has weight. So the weight, which is mg. And there's a contact force. So there would be friction and normal force. I'll write N for normal force, but if it's smooth, let's ignore friction. So here we go. This is the free body diagram for block 1. And we should all have the exact same drawing. Block 2, I'll draw it free of its surroundings. There. There's the rope with tension T. And again, for now, this is the same magnitude as this. Different direction, but same magnitude. Block 2 has weight as well. mg. And that's it. So we went from this to the free body diagrams, and there should be no variation among any of us. We should all have the exact same drawings. Step 2, however, this is where each of us could pick different coordinates. Okay, so you could pick coordinates like this, and that's perfectly fine. But for me, I'm going to go with, I know that block 1 is going to go toward the right. So I'm going to pick a coordinate going positive to the right. And I know block 2 is going to go down. So I'm picking my axes so that they're both moving in the positive direction. And I'm even going to name them the same axis. Let's say X. X. Right? So both blocks are moving in the positive X direction. You don't have to do this. For example, you could have picked, right, like the first one I drew, like this, right? So then block 1 is going to go in the positive X direction, and block 2 is going to go in the negative Y direction. And these are equal, and that's totally fine. But I will forget about the minus sign, and I'm going to mix up X and Y. So my personal preference is, I'm just going to name them both going in the positive x direction. Okay, so that's kind of my personal preference. You can do whichever you feel comfortable with. There's no wrong choice. Okay, so now that we pick coordinates, let's write Newton's second law, but decomposed. Well, nothing's happening in y, right? So let's not even bother. Okay, so in the x direction for block 1, we got this force, T, and that's it. So the sum of all forces, there's only one of them, equals mass, m1, times acceleration, only the x component. Okay, now in the y direction, I picked y here, right? So that's positive n, negative this, and that's it, equals mass times acceleration, but only the y component. Okay, before going any further, I know that block 1 is going horizontally. It's not moving vertically, which means this is definitely 0. This is not always true. This is true for this example, right? So you can't just go around crossing this out at will, right? So specific to this example, this is 0. Okay, block 2. In the x direction, I picked x here, so that means this is positive, and that's negative. Equals mass 2 times acceleration. Okay, so let's say we know the mass of the 2 blocks. So what's left that's unknown? We don't know this, we don't know that, this. Okay, so there are 3 unknowns. But we have 3 equations, which means you can solve for all 3, right? So, for example, we can solve this immediately. So that was easy. Okay, now what about the other 2? I can take this and put it there, right? So minus t equals, and then I can move this on that side. And then just divide through. So therefore, okay, so I got the acceleration. And if I wanted to solve for the tension, just take this and just substitute it right back there, and I got tension. Okay, so I hope that makes sense. And the point really to focus on is the method, right? Following these steps. Okay, let's do some more examples after this. Thanks for listening. I'll see you on the next one.